Hi guys, today I'm here to talk about Gemini Embedding 2, the newest multimodal model from Google. It allows you to search across media, which means that now you can search a text item with an image or you can search for a video item through an audio. This is great because earlier in traditional search, you could only search within a particular media. That is, you can search within images separately, you can search within text separately, and if you have to combine the two of them, then you have to combine like two three pipelines together and then search within it, which was a lot of work. But here you can transform image, text, video, audio, everything within a shared vector space and search within everything, right? So the moment I heard about this model, the first thought that struck me was that, oh my God, how great it would be that I can now take a photo of a food item in a restaurant and then I can, search for its recipe. I made a demo to showcase how this model works, and needless to say, it is about food. So let's hop on. Okay, so this is my project repository. I will quickly show you what kind of files I am using. So this is a dataset loader. I have made a file called media dataset JSON, in which I have kept links to some images and some text. And then I have a file called embedding search. This is the most important file. This is the file which is actually enabling the model to convert image or text into embeddings, right? So because this is a simple demo, I have just kept two kinds of media here, image and text. You can of course keep many other kind of media, but here the demo is limited to these two types. So if you see this file, so first I have written the name of the model, then what kind of task I am aiming to use it for, and this is basically the embedding config, that how I want to configure the embeddings, and here I'm extracting the embeddings. So if you don't know what embeddings are, I'll just tell you very briefly. Embeddings are like representing a particular entity with vectors. So the vector looks like an array of many floating point numbers. So this is basically that. Okay, so here I have also got a function called embed text, in which this kind of response captures the embedding. Then for image I have this function, right? So this is like the basic structure. Then I have something called cosine similarity. So what I'm aiming to do here is that I will put in a picture, and in response it will give me similar text or similar images, and I'm calculating the similarity by this function called cosine similarity. Okay, so this is it. Then I have this app.py. This is nothing but a file which when I run, it will open up a Streamlit interface. I've kept a Streamlit interface so that it's easier for you to visualize, right? Now the most important thing is the data set, how I have made it. So here you can see that there are just a lot of text things. These are like short recipes. So basically the image which I have chosen is this very viral dessert which was like dipping uh, Biscoff into this kind of a yogurt. So that's why I have kept some media related to that. So I have some short recipes relating to Biscoff yogurt dessert, then chocolate lava, then strawberry cheesecake, tiramisu dessert, then some unrelated things like ramen noodle, Oreo milkshake. Then I also have some random text like rocket launch, space mission, startup, fundraising. Then I have all these image paths. So I have this folder called images, in which I have kept some related images like these, uh, but unrelated, like pizza, ramen. I have a yogurt image also, which is basically fruits with yogurt, but not the Biscoff. Okay, so great. So now let's see it in action. Okay, guys, so this is my Streamlit interface. I dropped the original photo, and then it's given me the top matches. So if you can see that it has extracted this image into a vector containing 3072 dimensions, which is an array of floating point numbers. and all of the top matches have also been extracted into such arrays, and then the matches have come according to the cosine similarity. So if you see the top match, it is this, and it has got a similarity score of 0.8, which is quite high, right? And then next we have yogurt with fruits, which has got a score of 0.707. And then we have ramen, then pizza, and then the cake slice. I think what I did was the shape of these food items are circular, and what I gave was also circular. So that's why probably pizza and ramen came before the cake, I would assume. And see, all the text items come after the images. So if you look at this line, this is like a very small one-liner recipe. It's got a score of 0.441, which is far less than what the visual media got, right? So yeah, tiramisu recipe comes later. It's not really a recipe, it's just a one liner. I have kept it very simple because I'm operating on free tier here, and I just didn't want to make it a very complicated project. Oreo milkshake comes last. I had given it a threshold of 10 matches, so that's why you see 10 here. So yeah, this model is fantastic because it extracted text and images in the same shared vector space, right? And it gave you all the matches. Retrieval is never going to be the same again. Gemini has completely changed it.